Yeah, we are live. We are live. Just let me know my audibility. Let me know whether I'm audible or not. We are live, and I'm going to discuss one very good topic for mechanical engineers who are writing, who are going to write a HPCL paper. So, for mechanical, there is some basic electrical syllabus. So, in that basic electrical syllabus, the first part, which is very important, I'm going to discuss now. That is DC circuits. I think yes, I'm audible. Yes, I'm audible. I'm going to start with DC circuits. You know, a lot of syllabus is there from electrical, but you need not to study in detail. If you start studying in detail, no, it will take a lot of time. So here in classes, I'm going to cover total syllabus of basic electrical related to mechanical for HPCL written examination. See, in HPCL written examination, simple questions, very simple questions they ask, but I take some good questions, okay, so that simple question concept and some moderate level question also will be covered, right? So my heading here is, if any questions you have. Achyut, this class is for mechanical engineers, electrical only, but for mechanical, if you want, you people also can watch. Electrical people also can watch. Yeah, my heading here is DC circuits. Is DC circuits. I'll give the introduction by keeping mechanical engineers in mind. I'm taking this class. Electrical people know what is a voltage source, what is a current source, what is resistance, and what is Ohm's law, what is voltage division, what is current division, what is series combination, what is parallel combination, what is passive power sign convention. These things electrical people already know, right? But mechanical people don't know. That's why I'm teaching from very basic. Right, come here. All of you observe DC circuits. DC means a direct current, direct cycle, in fact, not current. DC stands for direct cycle. See, our power supply is of two types. Power supply is of two types. One is AC, alternating cycle. Another one is DC, direct cycle. Okay, so DC stands for direct cycle. Yes, direct cycle. And another one is AC. Simply we call this one as DC. Another one is AC, that is alternating cycle. Alternating, yes, cycle, that is AC, right? Two types of power supply we have. So we are discussing about the DC, direct cycle. So I'll tell you, I'm taking few, I think, basics. I can say basics, okay, which are very important. That is voltage. Voltage, I will define each and everything. Voltage represented with symbol V, then current represented with symbol I, then resistance, yes, represented with R, and reciprocal of resistance is conductance. Conductance, that is represented with a G, that is equal to reciprocal of the resistance. Reciprocal of the resistance. So we have these things with us. So somebody answers, sir, how many questions will come from in this section in HPCL examination? Say last year only 2 questions came, frankly speaking. We don't know how many questions will come. Maximum of 15 can come. Yeah, there are situations where when a new syllabus is introduced or new section or other section is there, you may get more number of questions also. Do not think that way. The one who messaged to me, yes, please do not think in that way. How many questions will come? No guarantee. HPCL is giving question paper for electrical, mechanical, whatever may be the branch. They are not maintaining consistency of the same number of questions. Suppose if I talk about electrical paper, if you see the subject like electrical machines, it's a big subject, in fact. And power systems, it is also a big subject. Sometimes from power system 10 questions only, sometimes it is almost 20. 10 to 20, 10 is the difference, almost 50% extra. So they are not maintaining consistency. Okay, if you say from this subject is very important, from that only 4 questions may come, right? And if you say some subject is very less important, from that they may give some 10 questions. So HPCL is not maintaining consistency in giving the question paper. They are not, consistency means they are not giving the same standard of questions. Okay, so that's why please leave the question. How many questions will come? We can't say. And one more thing, whatever that is there in the syllabus of mechanical, in mechanical, whatever that is electrical syllabus is there, no, in that +2 physics is also added. Okay, don't think that it is exclusively from electrical engineering. That is from +2 physics of intermediate. Yes, +1 +2, sorry, in that +2 physics part is also there, like electrostatics is not there, electromagnetism is there, right? We will see those things also, right? In the last papers, questions were asked from electromagnetism. Direct one formula they asked, direct one formula, and questions asked on capacitance. But don't think that, sir, let's discuss only electromagnetism or electrostatics or capacitances. No, why? Because if already that fellow given questions on electromagnetism, this time you'll ask question on Ohm's law. We don't know, right? So that's why very carefully, precisely, all the corners we are going to see. And the questions are not tough. Questions are not tough is going to ask damn simple questions. Means if you have the basic of the concept, yes, you're going to answer. If you have the basic, right? So that's why concentrate. See, number of times we already told this one, that is HPCL is going to test your width, not the depth. Means it will test whether you studied all the corners of all the subjects or not in depth, just basically, right? Come here. So conductance is G. So these are the some terms what we are going to see. Those who are from mechanical, please concentrate. So what my point here is, first I will take some analogy, that is I want to tell you what is voltage, what is current, and all these things. My analogy: if there is one pipe, yes, pipe, yes, and there is some water here. There is some water here in the pond. There is some water. This is. Now I want to send this water through the pipe to this end. What shall I do? What should I do? You put one pump here, motor. Okay, put here, that is going to force the water from this end to this end, right? In the same way, let me tell you about these things. In the same way, if I have a voltage source, DC voltage source, yes, this is a symbol of DC voltage source. This is a symbol of, let me write in that place. This is DC voltage source, right? Yeah, that is a symbol of DC voltage source. We represent with V. Okay, and it is having two plates. One is bigger one and one is smaller one. Most of the times, bigger one is taken as plus, smaller one is taken as minus. Bigger one is plus, smaller one is minus. Okay, voltage is going to have polarities. Current is going to have direction. Let me write that point here. Voltage is having polarities, that is plus minus. Voltage will have polarity. Come on. Current will have direction. Means A to B or B to A. Current is going to have direction, right? So what is the purpose of this DC voltage source? See, an example DC voltage source for you to get a better insight idea is a battery. Take one simple battery. See, your cell phone is having battery, or the remote control at your home. Yeah, this is AC remote. It is going to have batteries. Those are DC voltage sources. Now, I told you voltage source is like it is like force. It is analogous to force in mechanical. Okay, so if that is force, it is going to do some work. Yes, it is going to do some work. Now I am keeping one resistance here. Resistance means it is the opposition for the flow of current. Yeah, resistance means it is the opposition for the flow of current. Don't think in negative way. Resistance means it is not going to allow the current. No, it will allow the current, but it will oppose the flow of current. Deny is different from the opposition. Suppose I will tell you a very simple example, as you guys are from mechanical, to understand about resistance very easily. When you are walking on the floor, there is friction. Now, can you tell friction is opposing your? Can you tell friction is denying your movement? No. Without friction, you can't move. First of all, friction, yes, it is opposing your movement, but without friction, you can't work. Here also, resistance R is going to oppose the current. Its units are ohms. Resistance units are ohms. For you, for mechanical guys, this small, I can say units, all these things are very, very important. Now, this combination is called as circuit. This combination is called as circuit. Yes. Monica Kumari, is there any live class for electrical? You are talking about which subject, ma, Monica Kumari? This is for mechanical. All basics I am taking. Okay. See, this is called as circuit. What is a circuit? Closed. Yeah, it is connected closely. If there is a closed path, then it is called as a circuit. See, you connected some voltage, you connected some resistance. What Mr. Ohm is saying, there is a scientist called Ohm. Yes, Ohm. What he's saying is Ohm's law. We are going to discuss about Ohm's law now. What Mr. Ohm saying is the current through any resistance is directly proportional to voltage and it is inversely proportional to the resistance value, then current I is equal to V by R. That's what he's saying. Yes. If you apply some voltage across any resistance, then that voltage is forcing some current to flow. Yes, if you see current direction, I told current is having direction. Current is having direction. Sir, how to know the direction of the current? That depends on the question. That depends on the question. Here I take a voltage. Suppose if it is of 10 volts, if it is of 10 volts, yeah. Now current will be, yeah, I'll find out the current, I'll tell you later. But first of all, let's understand this terminology. Let's understand this terminology. That is, current I is equal to V by R. From this one, from this formula can be written in three ways. I is equal to V by R, or the same can be written as V is equal to I into R, or the same can be written as R is equal to V by I. R is equal to V by I. So the units of current are amperes. The units of voltage are volts. The units of resistance are ohms. Right? So that is basic formula. V is equal to I into R. I is equal to V by R. R is equal to V by I. That is a basic formula. Right? Now here, circuit is closed. Now current is flowing this way. That is I is equal to V by R. Now, sir, how to decide the direction of the current? That depends on the problem, as I told you. That depends on the problem, as I told you. Observe here, please, all of you. Now, I taken some resistance here. Yes, and I applied some voltage here like this. Let's take this resistance as A. This is terminal A. This is terminal B, and this is 5 ohms. This is plus minus 10 volts. This is plus minus 10 volts. Okay, so as water flows from I can say higher level to lower level, right? Yeah, water always flows from high slope to low slope, so it follows slope, right? Here also always current flows from high potential to low potential. Current always start from high potential to low potential, right? Observe here, which one is high? Plus is high, minus is low. Therefore current will start from here. How much current is flowing? If you want to find the current, amount of current that is flowing in this one, so I how much is the voltage? See, voltage, we call that as voltage across resistance. This is the terminology, voltage across resistance. This is my resistance. How much is the voltage across that resistance? Yes, 10 volts divided by the resistance. How many amperes it is? 2 amperes. Yes, 2 amperes of current is flowing in the resistance. This I is equal to 2 amperes. Now the same question, see, same question I'll do in multiple ways. Same question I'll do in multiple ways. The same question I given like this. The resistance. So this is A, this is B. Yes. Same voltage I'm giving. Same voltage I'm giving. This is 5 ohms. This is plus. This is minus. This is 10 volts. Now, if you observe carefully, now here this way I'm choosing I want the value of I told you current always flow from higher potential to lower potential. So the actual flow of current direction is this one only. You take this current, do not name it. How much current that is flowing? This is 2 amperes. But the direction of current, what the examiner want is exactly opposite to the direction of actual current flow. Yes, repeat. The direction of current flow is from A to B, but the direction what examiner is taken from is B to A. Means What he is asking is exactly opposite to what it is happening. Therefore, I is equal to minus 2 amperes. So current is negative. It means you assume some direction of current, but it is flowing the opposite to the direction. Right? Yes, I repeat, you assume some direction of the current, but it is flowing exactly opposite to that. That's why current is minus. Right? Now, here about voltage also, see, come on, about voltage also, this is plus minus I given. This one is 100 volts. You know what does it mean by this? See, this way also I can denote a DC voltage. For the DC voltage, this is one way of representation. That is another way of representation. So which one is said to be having higher potential? Always plus is at higher potential, minus it is at lower potential. Now we are going to see the special cases here. I'm taking this one as point A, this one as point B. I want VAB. I want VAB, voltage across A and B. So VAB is dash is my question. VAB is dash is my question. So he's asking about VAB, na? Means first point is A, next point is B. Means you put plus at A minus at B and write down VAB this way. Okay, I repeat, he want VAB, then you put a plus at A minus at B, then put VAB. Now you tell me this VAB, this is plus, yes, plus is matching, minus is matching. Therefore, I can write that VAB is equal to 100 volts. I can write that VAB is equal to 100 volts. What are the other cases? Let us see. What are the other cases? Let us see. Now, this is plus, this is minus, same 100 volts. This is A, this is B. Now I want VBA. Anyone please here in this session? Yes, there are some 12 to 13 students are there in the session. Please comment on the answer, please. What is VBA? Yes. Mechanical students, electrical students easily can answer this one. Mechanical students, yes, I'm waiting for your answers. Yes, there are some 12 students who are at this session, right? As I told you, the same process. You want VBA, no? Put plus at B, minus at A. What you want is exactly opposite to what it is there. Therefore, VBA is equal to 100, but it is minus 100. Why it is minus 100, sir? What you want is opposite to what it is there. Right? So it is minus 100. So this is how we have to see what it is there. Now it's other combinations also. Let me take its other combinations also. See why I'm teaching all these things. All these things are very simple things. The examiner will think that you all know these things, that he may ask a question. Okay, A and this is B. I want VAB, please. I want VAB. Yes, VAB. So put plus here, put minus here, plus minus opposite, therefore minus 100 volts. Next combination is sorry, minus plus. Yes, this is A, this is B, this is 100. I want VBA. So VBA, put plus here, put minus here, therefore it is 100 volts. Right? So this way we can understand. This way we have to understand the concept, right? So voltage and current. You know, if there is some voltage is like force, and if there is some resistance, if you connect those two, that is called as circuit. In circuit only current will flow. See, suppose water will flow in a pipe. Suppose if the pipe is broken, water will get spill away, but water is not going to flow in our required form. In the same way here it is somewhat we have to apply our brain. That is, current will not flow in if the circuit is broken. Right? Current will not flow. Come on, here I'll tell you some few basics here. That is, there is some 10 volts. There is some 10 volts. 10 volts. Here I connected some resistance of 10 ohms. Now I just left it open. Then I'm asking current. How much is the current? Yeah, here also you can apply Ohm's law. Right? That is I is equal to V 10 by R. R1 is 10 ohm plus Here nothing is connected though. If nothing is connected like this is called as open circuit. What is this? Open circuit. This is called as open circuit. Open circuit resistance is infinite, to remember. The resistance of open circuit is infinite. Therefore, how much is the current? 0 ampere. Something by infinite is 0. No current will flow. No current will flow in open circuit. Please do remember that point. Sir, why no current is flow? No closed path for the flow of current. No closed path for the flow of current. Current always travels through some medium, not through air. Not through air. Okay. Here nothing is there. Therefore, current is not flowing. So this way also you can understand, sir, why open circuit resistance is infinite. First of all, from our common sense, I is equal to 0 in open circuit. Why? Current cannot flow through air. If current flows through air, by this time we all might have been died. Why? Because all these wires are kept outside. If current is flowing through the air, we are here. Wire is there. If current is coming through air, that current what is that is there in the air that is going to flow through your body, you will die. Right? Current will not flow through air. There are some special cases where current flows through air also, but being mechanical engineers, you don't want all that analysis. Okay, simple things only I'm taking. Current is 0 in open circuit. So what is the formula of I? I is equal to V by R. If current is 0, yes, we know that voltage is some voltage by how much should be this value so that this is 0. Therefore, resistance of open circuit. Let me put here, resistance of open circuit is infinite, right? Resistance of open circuit is infinite, right? Now, one more point I want to tell you, that is, suppose, observe here, please. I'm taking this way. This is V, this is plus, this is minus. This is resistance. Yes, this is some resistance. Yes, I'm closing this one. So I given the current as I is equal to V by R. Now its opposite is or its converse is, whenever a current of I flows through a resistance. Himanshu sir, this will come in E or mechanical. This class is exclusively for mechanical. Anyhow for electrical, all these things are there. Okay, Himanshu, this class is exclusively for mechanical guys, and this is equal important for electrical guys also. For electrical, see, for you people know all these things. That's why this much basic not required. You know, mechanical students, listen to me carefully. Suppose if he is giving one simple circuit which you studied in +2, yeah, parallel combination of resistances, series combination of resistances, all these things you studied in +2, right? He gives one circuit, he's asking the current, he's asking the power. What will you do? He mentioned in the syllabus very clearly DC circuits, in fact DC theorems also. There are theorems like superposition theorem, Norton's theorem, Thevenin's theorem, maximum power transfer theorem. He mentioned theorems. He mentioned about transformer, induction machine, DC machine, synchronous machine. Okay, and Biot-Savart's electromagnetism, Biot-Savart's law. Lot of things he mentioned. Himanshu, how to prepare for E if gate not qualified for HPCL? See that one only, na. So Himanshu, you are talking about you are an EE student, right? See, in the last, I'll provide my phone number, yes, or otherwise take now itself 891-9999-705 is my contact number. You please contact me, I'll guide you separately. Okay, in this class, I have to teach to mechanical students. Okay, I'm teaching mechanical students. Listen, yeah, here when a current of I flows through a resistance of R, then some voltage is going to drop. Voltage is going to drop across that resistance. That voltage drop is taken as I into R. From Ohm's law, yeah, V is equal to I into R. Where the current is entering, the terminal is taken as plus, the current leaving terminal is taken as minus. I repeat, whenever current flows through any resistance, let me write that point, right? Let me write that point. That is, whenever I hope you taken my contact number. Whenever current flows through a resistance, then voltage drops across that resistance, across that resistance, and that voltage drop value is equal to I into R, comma, this is very important, current entering terminal is taken as positive, terminal is taken as positive, and current leaving terminal is taken as current leaving terminal is taken as negative, right? So this one very important, current entering and current leaving. Yes, some messages in the chat box. Jatin, some previous year HPCL paper discussion not found. For which branch you are asking? For electrical, I discussed in the last time. Yes. For E, yeah, I discussed 2023 paper. Yes, 2023 paper I discussed. You can find it on YouTube. Okay. Yes, please. Now observe here. That is one point you have to remember. Now I'm going for few things like KVL, KCL. We are done with Ohm's law. Then we have to go with the KVL and KCL. Basic things, +1, +2 things only. I'm not speaking about engineering things. I'm discussing very basic things. That is Kirchhoff's voltage law. This is KVL, Kirchhoff's voltage law. I'm not writing its full form. Yeah, he may ask KVL stands for mechanical students. We don't know because HPCL is giving that much easy questions. KVL stands for what? Kirchhoff's voltage law. KVL. What KVL says is, according to KVL, sum of all the voltages in a closed path must be equal to 0. Yes, according to KVL, sum of all the voltages in a closed path, must be, yes, equal to 0. Sum of all the voltages in a closed path must be equal to 0, right? So let me give you one question, Himanshu, sir, at what time must be evening 5 p.m.? Yeah, please message me through WhatsApp. I'll reply to you, Himanshu. Okay. Now see what he's saying. KVL is that according to KVL, sum of all the voltage in a closed path must be equal to 0, and this KVL is derived from law of conservation of power or law of conservation of energy. Law of conservation of energy, law of conservation of power, both are same. It is derived from law of conservation of yes, energy or power. Yes, this may be a I can say from where the KVL is derived, maybe a question, maybe an objective question. The KVL got derived from law of conservation of power or energy. Let us do one simple problem. I'm expecting answer from mechanical guys. See how many mechanical guys are there here in this class? How many mechanical guys are there? Please respond. This is 10 volts. This is 6 volts I given, and I'm saying this one as Vx is equal to dash volts is my question. Yes, answer please. Yeah, Palash, yes, please answer please for that question. I'll solve anyhow that question. I'm going to solve. Please answer it, all of you. Answer it. Yes, try it please. Yes, one simple question I given. I am expecting answer from mechanical guys. Electrical guys, please don't answer. That is dead easy question. You people will easily answer. This class is exclusively for electrical students, not for mechanical students. Okay. Answer please. Yes, people answered it. Yes. 4 volts. Yes, yes. Palash given 3 answers. 0, 4, 4 volts. Okay, fine. Let us see. Let us see. It is plus 4 or minus 4, Palash? Yes. Plus 4 or minus 4. So these are the options I am going to give you. So option A is plus 4. Option B is minus 4. Option C is some 6 plus 6. Option D is minus 6. It is very clear that it is a 4, but it is plus 4 or minus 4. It is plus 4 volts. How to write KVL for a given circuit, I am going to tell you now. Sir, where I have to start when I'm writing KVL? Where I have to start? That is your wish. Wherever you want to start, you start there. But I always suggest all of the students to start always at the minus terminal of the source. I repeat, I suggest always, it's suggestion, it's not a rule. You start anywhere, no problem. But I suggest personally to start at the negative terminal of source. I'm starting at negative terminal of source, that is minus, what is the value? 10. And choose one direction. I'm going this way. As I'm going, yes, I encountered plus 6. After that, I encountered plus Vx. All that must be equal to 0. So what is KVL? Wherever you start, again, you have to end there. I started here. I came to plus Vx means I came here. This point, both are same. Therefore, this is done. So Vx is equal to 10 minus 6, that is equal to 4 volts, plus 4 volts it is. Yes, that is about KVL. Next one is, yes, these are the problems I taken, but let me complete the important topics, theory topics, right? Yeah, and I'm covering questions also. See, slowly develop your electrical things. Sometimes, yes, as I told you, 15 questions, maximum of up to 15 questions they may ask in your HPCL. 15 is a very big number. Okay, it is going to decide your selection. That's why please concentrate very well here. Next, KCL. What is KCL? Kirchhoff's current law. Kirchhoff's current law. KCL. What is this? Let me tell you what is Kirchhoff's current law. The current entering or the sum of, let me write here, the sum of currents entering a node. What is a node? I will tell you. Don't worry. So terminology is new for you. Don't you worry. I'll tell you. Sum of currents entering a node must be equal to sum of currents leaving that node. What that fellow says is, whatever may be the current that is coming to a node, the same current must leave. Why? Because node is a junction. For example, you take railway station. What are the train that is coming to railway station? Okay, suppose if you take not a big station, some small station. What are the train that is coming to the station? The same train has to leave. 10 trains are coming. All 10 trains must leave. So node means it's a junction. It is a junction. Junction means where more than one element is connected. See, suppose I'll write like this. Here, yes, this way I connect. Okay, I say this one has R1, this one has R2, this one has R3. So who is giving current? Why these are connected? All those things you leave. Who given? Why those are connected that way? You leave. All those you leave. Now, so current of I is coming here. I1 is coming here, and this is I2 and I3, right? According to KCL, at this node, what is the current that is coming? I1 is coming. That is equal to sum of the outgoing I2 plus I3. Sir, what is KCL? So yeah, next question is that one only. From where KCL is derived, we'll see. First of all, let's see the definition of current. What is current? See, I did not take in these definitions in the starting itself. I did not take it because if I take, you feel like I am teaching some physics. Yeah, physics also is included in your syllabus. What is current? The rate at which charge flows, at which charge, electric charge, in fact, the rate at which electric charge flows is called as current. It's called as current. That is, I is equal to d q by dt, where q is charge, electric charge. Basic property of material is charge. Basic property of the material. Okay, right? Charge, and its units are coulombs. Yes, its units are coulombs. This is seconds. So the units of current, I units are coulomb per second, or current is introduced by a scientist called Ampere. On behalf of his name, we are keeping its unit as ampere. Ampere or coulomb per second, both are same. Means suppose if you take one wire, this is a wire, this is wire. In this charge is flowing. When charge will flow, see, if you take one body, this is the body. At this time, it is not having any, I can say, moving electrons. So electrons are moving, but those are moving randomly. Okay, it is not having a moving free electrons. What I do is I'll apply some force here, that is nothing but voltage. Then all free electrons will start moving in one particular direction. That movement of electrons with respect to time, is going to give you current. The rate at which a charge is flowing, coulombs per second. How many coulombs per second is flowing through some cross section, that is going to be current. Coulomb per second, right? Now, KCL is derived from, KCL is, or before I go for that one, yeah, you observe here, from the previous example, I1 is equal to I2 plus I3, we got. Can I write this one as a dq1 by dt is equal to dq2 by dt plus dq3 by dt gone. Therefore, you'll get q1 is equal to q2 plus q3. This is nothing but, yes, whatever the charge that is coming, the same charge must leave. Why? Because charge can neither be created nor can be destroyed. It's a basic property of the material. Yes, it's not in your hand either to create or to destroy. So from this one I can say, KCL is derived from law of conservation of charge. KCL is derived from law of conservation of charge. Yes, this is derived from law of conservation of charge. That's about KCL, Kirchhoff's current law. But Palash, it is not derived from law of conservation of energy. It is derived from law of conservation of charge. There is a proof for that. In fact, for KVL also there is proof, but don't go that depth. It will waste your time, valuable time. Okay, simple. Now come here. I'm giving one example. Find the current. Find the current. That is this. So this kind of questions, there is a probability to ask in your HPCL examination. That is charge through at some cross section. Charge through some cross section is 2 into 10 to the power of minus 3 into T coulombs. Then find the current. So options are 4 milliamperes, 2 amperes. Option C is 2 milliamperes. Option D is none. Yes. Mechanical people. Yes, I'm expecting answer from mechanical guys, not from electrical guys. Very simple question, please. Give me the answer, please. Yes. I'm waiting for your answer. Simple question, very simple question. I told Current is nothing but the rate of charge flow dq by dt. I is equal to dq by dt. Yes. Palash Kumar. Come on, man. Yeah. So simple. I given that q of t is equal to 2 into 10 to the power of minus 3 into t. I is equal to dq of t by dt is equal to 2 into d by dt of, sorry, d by dt of 2 into 10 to the power of minus 3t. So you are going to get it as 2 into 10 to the power of minus 3. That is simply nothing but 2 milliamperes. So one thing is applying that formula. Second thing is units of current. Third thing is calculation. These simple things are very, very important. Right? Now, I'm giving one more question here. Try to answer, mechanical guys. One more question, that is, there is a junction here, node, or let me take a complete circuit this way. That is, yeah. Otherwise, I taken some very good questions on the same concepts, which were asked many a times in previous PSU examinations. Yes, I'm going to take one question. Yes, please try to solve this question. Yes, try to solve this question. Yes, Shivam Singh. Yes, it is 2 milliamperes only. It's a very good question. Try to solve it, please, all of you. Here, apply KVL, KCL, Ohm's law. You have to apply all three. Yes, I given you the hint. You have to apply all three: KVL, KCL, Ohm's law. Previous PSU question it is. Please do it, please. You know, HPCL or any PSU, they are not going to prepare questions from somewhere. Just they pick some from some previous PSUs, at least the concepts, not maybe the exact questions. Okay, please do it, please. I'm giving you 2 minutes of time. All of you do it. This question you do it, please. All of you. Yes, yes. I'm waiting for your answer. This question, electrical guys also can try. Yes. Yes, yes. There are electrical guys like Achyut, Monica, Shivam Singh, mechanical guys Manish, sorry, Palash. Come on, yeah. It's very simple question. What is asking? In the circuit shown below, the effective resistance faced by the voltage source. So this is the voltage source. Now, as I told you today itself, just 20 minutes back, I told you that this is voltage source. Now he's asking, what is the resistance seen, R effective seen by the voltage source? So R effective, R is equal to, what is the voltage of the voltage source? V. What is the current of the voltage source? I. So you have to find the ratio to V to I. You have to find the, yeah, Palash Kumar. That is, Palash Kumar already given answer as 2 ohms. Very good. Let us see whether it is correct or not. I don't know answer, but I'll do it. Shivam Singh also given 2 ohms. Let us see. Let us see. Okay. But sir, here V and I want. This is I by 3. This is 3. Very simple thing I will tell you. This is a node, na? How much is coming here? I is coming here. In that, how much is leaving this way? I by 3. Right? KCL at node A. Right. Yes. KCL at node A. What is that? Incoming current is I. One of the outgoing is given as I by 3. Other outgoing we don't know. Let us assume this one as X. Let us assume this one as X. Right? Then X is equal to I minus I by 3. That is nothing but 2I by 3. X is 2I by 3. Right? X is nothing but what? 2I by 3. Okay. Now, if X is 2I by 3, let me erase this X. I got its value. This is nothing but 2I by 3. Okay. This is 2I by 3. But this will be plus, this will be minus. No. Why? Current entering part is taken as positive. Current entering terminal is taken as positive. Now, let us write KVL for this loop. Loop means closed path. Loop is a closed path. Anyhow, this is plus, this is minus. I'm writing minus V plus. I'm not writing for this one. I'm not writing for this one. Why? Because I don't know the voltage here. I'm writing therefore this way. Yeah, this is a closed path. Those who are unable to see, I'm showing this is my closed path. Yeah, what KVL says, sum of all the voltage in a closed path must be equal to 0, right? Minus V, yes, minus V. Come on, next, continue. Plus current is how much? 2I by 3 into how much is the resistance? 3 is equal to 0. 3 gone. So V is equal to 2I. So from this one, V by I is equal to 2 ohms. That is nothing but a effective resistance. Option is C. Very good, Palash. Very good. I didn't expect mechanical students to answer this question, but first answered by Palash only. Yes, yes, very good, very good. Okay, let's go back. Let us go back. See, don't think that this one only going to come in the examination, and don't think that this is not at all going to be useful in the examination. Both are wrong. Slowly I am building the basic concepts which are required for your examination. Once you have all the required basics, if any question is given, you are in a position to answer. If no question is given from this area, that is also fine. And don't think that, sir, all my effort got wasted. Imagine, see, the probability of giving or not giving is not in our hands, right? So please concentrate very carefully here. That is parallel combination and series combination. Understanding this parallel combination and series combination is very important. Parallel combination of element. Parallel combination. What is this parallel combination, sir? You take any two elements. Let us take. I'm taking two resistances. Okay. This is, or let's take three resistances. If I take two resistances, a little confusion may be there. Yeah, three resistances. If all the top portions are connected this way, all the bottom portions are connected this way, then all three elements are said to be in parallel. R1, R2, R3 are said to be in parallel, right? R1, R2, R3 are said to be in parallel. I'm writing. See, we should not learn this way, but basic understanding this one only. If I give you technical definition like if voltage is same across the connected elements, then those elements are said to be parallel, then immediately one question will pop up in your mind, sir, how to find the voltage, how to know whether it is same or not. Forget about all that. Okay, so if you connect all, see, all top portions to one common point, all bottom portions to one common point, those are said to be in parallel. Now one note point here is one very good note point about parallel connection. Voltage is same. Voltage is same across all parallel connected elements. Parallel connected elements. Let me take up one simple question. Yes. This is 10 ohms. This one is 2 amperes. V is equal to dash volts. Answer. This V is dash. Yes. Answer, please. Mechanical guys. First priority is given for mechanical guys. Yes, V is dash. Simple question. Yes, I'm expecting answer from you guys for this question. Simple question. Please do not. Yes, Palash Kumar, very good. See, current is flowing how much? Current is flowing how much? 2. When 2 amperes is flowing, this is plus, this is minus, this is 20. These two are in parallel, right? In parallel, voltage must be same. That is 20 volts. Plus is connected to plus, minus is connected to minus. Or another way is, write KVL. What is that? Minus V plus 20 is equal to 0. Therefore, V is equal to 20 volts. So what is the note point I given? Voltage is same across all parallel connected elements, but current will divide. But current will get divide. Right? Let me give you one more question. Yes, that is. So this one, the current is 2 amperes. This one is 6 ohm. This one is also 6 ohm. This is plus minus V. I'm taking this one as current I. Find V comma I R dash volt comma dash amperes respectively. Find it, please, all of you. All of you find it, please. I'm giving you 2 minutes of time. Do it, please. Yes. Answer, please. Yes, Palash, very good. 12 volts and 2 amperes. Yes, it is very simple. It's very simple. Yes, that is. Observe here carefully. Slowly, I'll increase the depth of the questions. As it is the initial stage, no, I'm not taking. See, first of all, when 2 amperes of current is flowing, what is this voltage? 12 volts. Then you write KVL for this one. How much is minus V plus 12 is equal to 0, V equal to 12. Or very simply, voltage across parallel elements is same. Na? This voltage is 12. This voltage must be 12. This also must be 12. If 12 volts is there here, 12 divided by 6, how much it is? Current I. How to get the current I? I is equal to voltage is 12 divided by 6 ohms. I is equal to 2 amperes. 12 volts, comma 2 amperes. That's all. Right? Any question in the previous problem? Any questions you have in the previous problem? Please, all of you. Mechanical students. Right. Now, I'm giving, next one is series connection. Next one is a series connection. Series connection. If current through the connected elements is same, then those elements are said to be connected in series. If current through the connected elements is same, then those elements are said to be connected in series. Let me take one example. That is, you have one resistance here, you have another resistance here, you have another resistance here. This is R1, R2, and this is R3. Yes, you see the shape of the connection, it may be anyway. The current whatever that is coming I, the same current is flowing, therefore R1, R2, R3 are said to be in series. If current is same through the elements, then those elements are said to be in series. If voltage is same across the elements, then those elements are said to be connected in parallel, right? Current is same, series. Voltage is same, parallel, right? Observe here, please. One question I'm giving. Yes. This is the question I'm giving. This is 2 ohms. This is 6 ohms. Yes. This is 4 ohms. This is plus minus V. This current is I. Now, I. And I'm giving I is equal to 1 ampere. I want this voltage V1. I want this voltage V2. I want this voltage V3 and V. So V1, comma, V2, comma, V3, comma, VR dash 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 respectively. Please tell me the answer, please, all of you. Mechanical guys, this session is exclusively for mechanical guys. Okay? Yes. Answer, please. Yes. Tell me the value of V1, V2, V3, and V. Yes. I'm waiting. Palash Kumar. So after this resistances connected in series simplification, parallel simplification also I'm going to take it up. Palash Kumar answered, that is 2, 6, 4, 12. Perfect answer it is, please. Perfect. Simple. See, what is V1? V1 is equal to current into resistance R1 is 2. So current is 1 ampere into 2 is 2 volt. Second one, V2, current is 1 ampere into resistance 6, that is 6 volt. V3, yes, current is 1 ampere and resistance is 4 volt, it is 4. But what is this V? Summation of V1, V2, V3, KVL, right? KVL, that is, I can say 2 plus 6 plus 4. Yeah, first one is 2, next one is 6, next one is 4. This is 12 volts. 2 volts, 6 volts, 4 volts, 12 volts, right? Next, if resistance is connected in series, if 2 resistances, let's take, if 2 resistances connected in series, that is R1 and R2 here, this can be represented with single resistance called R total, that is equal to R1 plus R2. So from this one, what you have to understand is, yes, from that one, what you have to understand is, if resistances connected in series will be simply added. Resistances connected will be simply added. See, by keeping mechanical students in mind, I'm teaching these basics. If it is for electrical, that is, these things I never even discuss. Those are very, very simple things. Okay. So if 2 resistances connected in series, then RT is equal to R1 plus R2. If 2 resistances connected in parallel, if 2 resistances connected in parallel, this way, parallel connection is this one. Yes, this is R1, this is R2. Now this is RT or R equivalent I'm going to get. RT or R equivalent I'm going to get. That is R equivalent is equal to R1 R2 by R1 plus R2. R1 plus R2. So more simplification for that is, if resistances are connected in parallel, then this is the perfect relation, that is 1 by RT is equal to 1 by R1 plus 1 by R2. If this is for parallel connection, now RT is equal to R1 plus R2, and this is for, yes, series connection. This is for series connection. Okay. So now based on that, I'm giving some questions. Yes, let us solve these questions. Yes, previously asked PSU questions. Okay, previously asked PSU questions. There are a lot of things to discuss. I'll discuss those things when time comes. There are a lot of things. Okay, yeah. Answer this question, please. Answer this question, please. All of you. Yes, 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 please. Please, all of you, mechanical guys. What is saying? A 10 ohm resistor is connected in parallel with 15 ohm resistance. Okay, 10 ohm is connected in parallel with 15 ohm. Fine, that's fine. That is connected in series with a combination of 12 ohms. That way is saying. Yeah, a 10 ohm resistor is connected in parallel with a 15 ohm resistor, and the combination is in series with 12 ohm resistor. The equivalent resistance of the circuit is, so R equivalent from here is asking what is R equivalent. Yes, simply R equivalent is equal to, these two are in parallel. What is the parallel combination of resistance value? R1 R2 by R1 plus R2. How much it is? 10 into 15. So 10 into 15 by 25 plus 12. This is in series, no? So you assume this one as one resistance after combination. This is R2, R1 plus R2, right? So 3 5s, sorry, 5 3s. Yeah, sorry, just 5 3s. This is 5 5s. So 6 plus 12, it is simply 18 ohms. Yes, option is C. So I picked some electrical questions which were given in previous mechanical PSU exams, not exactly HPCL. This, okay, these are the questions previously asked. See, I'm covering all the topics one by one. Without having the basics of these things, going further is going to be difficult. So the same notes will be provided to you as I given my contact number. Yes, this is my contact number. You can take, message me. The same notes I'll forward it to you. Okay, I think this area is visible to you. 89199999705 is my contact number. Okay, please message through WhatsApp to this number. I'll provide you these notes and the problems also, right? So this is the very first session on YouTube for mechanical guys, this electrical syllabus, basic electrical. Okay, do not jump into the topics like theorems or AC analysis, or I can say synchronous machine, or I can say transformer without knowing this. Having the idea of voltage, current, power, charge, okay, capacitor, inductor, flux, without knowing these things you can't do anything. Just you have to mug it. But you know that no question we are going to solve if you mug, but because on the same concept the questions may not be given in the upcoming examination, right? We'll meet in the next session. I provided you my number. Please message me if you have any sort of questions, right? All the best.